Everyone, so today we're going to focus on how to multiply binomials. We're going to take a look at two different methods, and then you pick whichever method you feel more comfortable with. So the first method we're going to talk about is called the box method. It might also be called the area model, depending on where you went to school before this. So we need to multiply the following. We have x plus 3 times x minus 4. So step number 1 here is to create a box, one row and one column for each term. So these are binomials, so we have 2 in both set of parentheses here, so we're going to have a 2 by 2 box. So let me draw this box. And what we're going to do is assign a polynomial to each side of the box. So I'm going to put x plus 3 on this side, and then I'm going to put x. Actually, I'm going to even put that in a different color, and I'll explain why. Put that in green. X minus 4 over here. So these polynomials need to stay together. So our x plus 3 needs to stay together, and our x minus 4 needs to stay together. I'm also putting the signs in front because I need you to treat that like a positive 3, and then I need you to treat this at the top like a negative 4. So from here, we're going to multiply corresponding sides. So we have x times x. That's what's going to go in this first box, x times x. Okay, so we have our invisible coefficients if you want to put those in, and our invisible exponents here if you want to put those in. 1 times 1 is 1. And then we have to add our exponents here. Don't forget that. Whenever we're multiplying terms with like bases, we're going to add our exponents. So 1 plus 1 is 2. So this first box is 1x squared. Now the second box, what's going to go here is we're going to multiply x times negative 4. So x times negative 4. We have 1 times negative 4. That gives us negative 4. And you can see here that we don't have an x. So we're not going to multiply this x to anything. So we're just going to bring it over. Don't add exponents, just bring that x over. Now in this box, we're going to multiply x and 3. So our 1 times 3, that gives us 3. And then I'm going to just bring that x to the first power down. This does not have an x, so we don't have any exponents to add to it. Now in this last box, we're going to multiply 3 and negative 4. So this 3 and this negative 4. Now, positive times a negative is going to give us a negative, and 4 times 3 gives us 12. Okay, so I'm going to just erase these arrows for now. So this is what we have so far. We multiplied corresponding sides, which was step number 3. Let's take a look at step number 4. Identify and combine like terms. So I'm looking at all of the terms in this box, and I'm going to circle my like terms. I'm going to do that in yellow. These are my like terms. They have the same variable and same exponent. So I need to add those together. So what I'm going to do right now is I'm going to just rewrite our polynomial. I'm not going to put the 1 in because it's unnecessary. We don't need it. So I have x squared minus 4x plus 3x minus 12, and we're going to add those polynomials over here. These terms here. So negative 4x plus 3x, that gives us negative 1x. Like I said, we don't need to put that 1. And then I'm going to just bring down the terms that we didn't touch. Okay, so I just combined my like terms. Negative 4 plus 3 gave me a negative 1. So that's why there's this minus x here. Now it's in standard form. I have nothing else to combine. So we have to make sure our answer is written in standard form, which it already is. So I'm going to leave it just like it is. So that's our answer. X squared minus x minus 12. Okay, let's take a look at another example. For this example, we are going to use the distributive method. Okay, so basically what we're going to be doing is distribute the first term twice and then distribute the second term twice. This is also called the FOIL method, if you've heard of that before. So what I'm going to do is I'm going to take this first term, this 2x squared, and I'm going to multiply that to the both terms in the second set of parentheses. So I'm going to just write my work over here. I have 2x squared times x squared, and then I have 2x squared times 6. Now, if you want to, go ahead and put your invisible coefficient there, and we're going to multiply from there. 2 times 1 is 2. Add your exponents, so that's going to give me x to the 4th. Now I'm going to multiply the second set. 2 times 6 is 12. The 6 does not have an exponent. It does not have a variable for us to add the exponents with, so I'm going to just bring my x squared over. Okay, so that's the first part. Second step, we're going to use the distributive method property for the second set of terms. So we have a minus 5 here, and we're going to distribute that twice. So we get negative 5 times x squared and negative 5 times 6. If you want, put that invisible coefficient. Now, negative 5 times 1 gives us negative 5. We don't have any variables to add, so I'm going to just put x squared here. And then negative 5 times 6 gives us negative 30. Third step, just like what we did before, identify and combine your like terms. So we're looking for variables that have the same variable, same exponent, which is these two terms here. So we're going to add those coefficients. Don't touch the exponents here. Now, 12 plus 5, that's going to give us 7. And then leave the exponents alone. So we get 7x squared. I'm going to write my polynomial as one big polynomial because that's the second step. Write your answer in standard form. The fourth step, write your answer in standard form. So we get 2x to the 4th minus 7x squared minus 30. It's in standard form, so I know that we're good. Okay, let's take a look at another example. So I'm going to be using the box method for this example. So the first thing is I notice that it's multiplication because there's no addition right here. There's no subtraction. There's nothing in between those sets of parentheses, so I know it's multiplication. So I'm going to set up my box here. So I'm going to make it a little bit bigger. Now that I have a little bit more space on the side. So I'm going to put my 3x plus 2. Now, very important, you cannot do this. Do not do this. That 3x and that plus 2 have to stay together on the same side. So if we put our 3x over here, then we need to also put our plus 2 on that same side. Now I'm going to put the second polynomial at the top. It doesn't matter which one goes where, like if we put that second polynomial on the side or on the top, as long as we keep the terms together. That's what really matters. Okay, and now I'm going to multiply. I'm going to multiply those corresponding sides. I'm going to just put those invisible exponents to help me keep my thoughts together. So I have 3 times negative 6. That gives me negative 18. Add your exponents, you get x to the 3rd. Now this second box here, we have 3 times 5. That gives us 15. Add your exponents here. 1 plus 1 gives us 2, which is x squared. Now for this box, we have 2 times negative 6x squared. 2 times negative 6 gives me negative 12. And then this does not have an x, so we can't add the exponents, so I'm going to just bring down that x squared. Don't add the exponents. Now for this last box, 2 times 5x, well 2 times 5 gives me 10. This doesn't have a variable, so I'm going to just bring down that x. Okay, I'm going to just erase these arrows. I'm just going to double check my work real quick. Is my multiplication correct? Did I add all of my exponents where I should have? please make sure that you're checking your work as you complete it, so then if you make a mistake, it's easier to catch. Now I'm going to identify my like terms, which is this 15x squared and this negative 12x squared. I'm going to add those together. But first, I'm going to just write it as one big polynomial. So we have negative 18x to the third plus 15x squared minus 12x squared plus 10x. And we have our like terms here. When we add positive 15x squared and negative 12x squared, that's going to give us a positive 3x squared. Different signs subtract, keep the sign of the larger, and then just bring down whatever you did not use, whatever was not included in that little addition. It's in standard form. We don't have any like terms, so I'm going to box my answer. And let's take a look at one more example. So here, this says x plus 6 in parentheses squared. So the first thing I want to do is I want to say, what is this asking me? What do I need to do here? I'm going to rewrite this. And I know something squared is something times itself. So this is saying x plus 6 times x plus 6. Just multiplying it to itself. Okay, so for this one, I'm going to use the double distribution method just to show both methods twice. I'm going to take this first term and I'm going to distribute that twice. So I'm going to just do that over here. We have x times x, and we have x times 6. Now I'm going to take this second term and I'm going to distribute that twice. So I have 6 times x and 6 times 6. Now I'm going to go ahead and do that multiplication. If you want to, fill in your invisible exponents and coefficients, just so you can see where all these numbers are coming from. Now for this first part, we have 1 times 1, which is 1, and then add your exponents of the variables, the like variables here, that's going to give us 2. So that is just the same as saying x squared. Now x times 6 just gives us 6x. 6 times x gives us 6x, and then 6 times 6 gives us 36. So we identify our like terms, which are 6x and 6x. We're going to add those together, and that gives us 12x. Now we're going to write our answer as one cohesive polynomial, which is x squared plus 12x plus 36. Make sure your answer is in standard form, and you're done.